Hi my dear friends, welcome back to our YouTube channel. This is ADC Max. See the title, Symmetric Matrices. When we say that the matrix is symmetric, first of all, tell me. Yeah, you are correct. The transpose of the matrix is equal to the matrix itself. It is known as the symmetric matrix. Is that right? Let us see the given matrix. It is the diagonal elements. The above the diagonal elements are similar to the below the diagonals. That means that what is A transpose is equal to A. That means that Aij is equal to Aji. So what about A12? 12 is 21. 13 is 31. 23 is 32. What about 11? 11, 22, 33. That's fixed. So that is the definition of the symmetric matrices. Okay. Now let's see that the topic is symmetric matrices with distinct eigenvalues. Distinct eigenvalues. So this is a 3 by 3 matrix. So there are 3 eigenvalues for the given matrix. Let us find out the usual way to find the eigenvalues of A with the help of the characteristic equation. Lambda cube minus S1 lambda squared plus S2 lambda minus S3 equal to 0. What about S1? S1 is the sum of the leading diagonal elements, or is often called as the trace of the matrix. So 8 plus 7 plus 3 it is 15 plus 3 is 18. What about S2? Sum of the minor. So through the diagonals. If we fix this diagonal first, this row and this column is eliminated. So 4 minus 7 minus 4, 3. The second diagonal is 7. This column and this row is eliminated. So 8, 2, 2, 3. The third diagonal is 3. So this is the column and this is the row eliminated. 8 minus 6 minus 6, 7. So let's find out the S2 value. 7 3s are 21 minus 16. Plus 8 3s are 24 minus 4. 8 7s are 56 minus 36. So it is 20, here is 20, 40, 40 plus 5, 45. What about S3? Is the determinant of A. So let us start the plus, minus, plus. So plus, so this row is fixed, this column is eliminated. So 8 into 7 minus 4, 3. Minus or minus, plus 6 into this row and this column, middle column. Minus 6, minus 4, 2, 3. And plus 2 into this row and this column. Minus 6, 7, 2, minus 4. So let's find out the value. 8 into 7 3s are 21 minus 16. Minus or minus plus 6 minus 18 plus 8. Plus 2 into 24 minus 14. So 20 into 2 40. And it is minus 10 is minus 60. This is 5 40. So 40. This is how much? 8 4s are 8 5s are 40. This is how much? This is equal to minus 10. So minus 10 minus 60. This is 10. So 20. So 20 plus 40, 60, 60 minus 60, 0. Let us substitute the S1, S2, S3 value. S1 is 18. So lambda cube minus 18 lambda squared plus S2 value is 45 lambda and S3 is 0 because the determinant value is 0 here. So 0. So there is no constant term. So no need to bother about the long division method or synthetic division method is called trial and error method. Don't bother about it because the constant term is not there. So better, that means that when we get the constant term is 0, definitely the product of the root is 0. So one among the root is 0 here. It is very clear. So that means that taking lambda as common, we get lambda square minus 18 lambda plus 45 equal to 0. It means that either lambda equal to 0 or this secondary polynomial equal to 0. The sum of the root is 18. Product is 45. So the numbers are 3 and 15. 3 plus 15 is 18. 3 into 15 is 45. So the eigenvalues of A are 0, 3 and 15. All these 3 are distinct eigenvalues. So symmetric matrix with distinct eigenvalues. This is the case. Now how to get the corresponding eigenvectors for these eigenvalues? Let us see that. As we know that the eigenvectors of A are given by the matrix equation A minus lambda into x equal to 0 matrix. So let us subtract lambda from the diagonal wise. 8 minus lambda, 7 minus lambda, 3 minus lambda, and x is the non-zero column matrix. X1, x2, x3, right hand side is 0, 0, 0. Let us cross multiply this. That means the row and column wise matrix multiplication. We get the first equation. Let us use the second row and this one, we get the second one, and the third row with this one, we get the third equation. So this is my system of equation in terms of x1, x2, x3. Our ultimate aim is to get the small x1, small x2, x3 for the various values of lambda. What are the various values? 0, 3 and 15. Let us substitute lambda equal to 0, 3, 15. What are the eigenvectors? Okay. Now you see that if you substitute the lambda equal to 0 in the star equation, I am getting that 8x1 minus 6x2 plus 2x3 equal to 0. And the second equation, minus 6x1 plus 7 into x2 minus 4x3 equal to 0. 2x1 minus 4x2 plus 3 minus 0, 3 into x3 equal to 0. To apply the cross multiplication rule, we at least need two distinct equations. Unfortunately, fortunately, all the three equations are identical. All the equations are distinct. So we can use any two equations. So I go with the first and second equation. So by using cross multiplication rule, the first and second equation, picking out the coefficients of the middle variable x2 first, minus 6 plus 7, the next 3 coefficient 2 minus 4, the next one coefficient 8 minus 6, and once again the x2 coefficient minus 6, 7. This gives the x1 value. So x1 is equal to 6 into 4, 24 minus 14 is equal to x2 by minus 12 plus 32 and x3 by 56 minus 36. This gives 10, 20, this is 20. Multiples of 10, so multiply by 10 here, we get 1, 2, 2. So this is the first eigenvector corresponding to lambda is equal to 0. Then the second case, putting lambda is equal to 3 in this equation star, 8 minus 3 is 5. So 5x1 minus 6x2 plus 2x3 equal to 0. Minus 6x1 plus 7 minus 3, 4. 4x2 minus 4x3 equal to 0. The third equation, 2x1 minus 4x2 plus 3 minus 3, 0, x3 equal to 0. Once again, all the three equations are distinct only, so we can pick any two equations. So for this case, I use the second and the third equations. Right, sir? Second and third equation. So by using cross multiplication rule, pick the x2 coefficients 4 minus 4, x3 coefficient minus 4, 0, x1 coefficients minus 6, 2, again 4 minus 4. So this will give the x1 value. So x1 by 4 into 0, 0. Minus of 16, and x2 is minus 8, then this is 0, we don't bother about it, and x3 by 6 4s are 24, minus 4 2s are 8. So x1 by minus 16, x2 by minus 8, x3 by 16. I think most of the terms are negative side, so we multiply by minus 8 plus 2 plus 1 minus 2. So this is my x2, the second eigenvector corresponding to the eigen value 3. What about the third one? The third one is nothing but the 15. So case number 3, substitute lambda is equal to 15. So putting lambda is equal to 15 in the star equation, so 8 minus 15 minus 7x1 minus 6x2 plus 2x3 equal to 0. Second equation, minus 6x1, 7 minus 15 minus 8x2 minus 4x3 equal to 0. I think so these two equations are distinct only. No need to write the even third equation, not necessary, because once when we apply the cross multiplication rule, we need at least two distinct equations. I think so these are two different ones. Say 7, 6 is there, 6, 8, 2, 4. So almost it's a prime number. So these two are two distinct equations, not necessarily the third one. Third one is if you want, please can you write it, otherwise not necessary. And I am going to use the cross multiplication rule at this time. So with this equation, so minus 6 minus 8, 2 minus 4 minus 7 minus 6 minus 6 minus 8. So this will give the x1 value, this will give the x2, and this will give the x3 value. So let us find out the x1, x2, x3. So x1 by 6 into 4, 24 minus plus 16, and x2 by 2 into minus 6 minus 12 minus only 4 2s are 28, 4 7s are 28. Then x3 by 8 7s are 56 minus 36. So what about x1? x1 by 40, x2 by minus 40, x3 by I think so 20. So it's a multiples of 20 only. So multiply by 20 we get x1 by 2, x2 by minus 2 and x3 by 1. So this is my third eigenvector corresponding to the eigenvalue lambda is equal to 15. So three different eigenvalues, 3 different eigenvectors corresponding to the eigenvalues. So this is the problem comes under symmetric matrix with different or distinct eigenvalues. Thank you. You may understand. I hope everyone is understand this problem. This is comes under the symmetric with distinct eigenvalues. So please kindly watch the symmetric with repeated eigenvalues in the other videos. Please kindly go and watch. Thank you. Thank you so much for watching our YouTube channel. Signing off. This is your ADC. Bye. Take care.